Okay, welcome back to another video. What we're going to talk about right here is we're still going to be talking about the theme of tennis, but I want to show you how to make an enemy that's controlled by the computer. So you know how lots of games you play against the computer. Now what I did here is I had this dude, player one, and he's awesome and I loved him and he was great. And I got all his sprites set up. I like the way he looks. I got his control set up. Once I got him ready, then I could just right click on him and say that I wanted to duplicate him. And here's that duplicate. So really I just duplicated him and got this guy. Now the great thing about him is he's got all the same costumes. He's still got the code about changing his costumes. I deleted his control code because I don't want this guy. So we're talking about this guy up here at the top. I do not want him to follow the keys. And by the way, it's just a good idea to, when you start the game, have him go to a certain spot so you don't ever lose him. So when the game starts, he's going to go to that spot there. And in the looks tab, there's change your color effect. So change color effect came from the looks tab. And all that means is he'll just change what color he is. You can play with that. So now all of a sudden he's Luigi, even though, so I didn't have to do any fancy painting. I just changed his color effect. Now, here's what's weird. I don't want him to move based on the keys. Now think about player one. Player one was like, if they press this key, I do this stuff, right? Well, that's not exactly how he should do it, but think about this. The computer, he still needs to either, in this game, point to the left or point to the right, one of the two, and move. So, what I would say if I were you, is I would first of all get into his brain, and he needs to make a decision. Now I would think about it like this. He's either going to face to the left or he's going to face to the right, which sounds like an if-else statement. So I'm going to take this guy, put him in there. Now, here's what's bizarre and what is going to make the difference for this computer. In the sensing tab, there's a block that lets you kind of look at somebody else and know their business. And it's down here, almost all the way down to the bottom, and it's I don't even know what to call it. It's got of, and it's got two drop downs. So I could ask, hey, what's the X position of player 2? Oh, I'm out of battery. I could ask what's the X position of player 2, but I don't really want to know the X position of player 2. What I want to know is the X position. I could ask for the direction of player 2. I could ask for all sorts of stuff. What I really want to know is what's the X position of the ball? No, not player 1, of the ball. That's going to be awesome. Okay, so you can ask what is the X position of the ball. You could ask anything you want to. What's the direction of the ball? What's the Y position of the ball? But what we really want to know is we're going to make our decision based on the X position of the ball. Now you'll notice that won't fit in that if statement because that if statement has to be asking a question. X position of ball is a number. It's not a yes or no question. So if you go into operators, now notice, see how all these things here all fit the shape of that if statement. And so what you want to know, let's build this up. This will go in here. And now you're in algebra class, right? If the X position of the ball is less than, and then let's go to motion. And don't forget, I'm in the brain of player 2. I want to compare the X position of the ball to, and this is in the motion tab, my X position. So you're comparing where is the ball and where am I? Now think about this. If the X position of the ball is less than my X position, so you can think math, here's me. Right now my X position is, you can tell by looking down here, so your mouse is always telling you what X position you're on. Right now, the computer is at his X is -9, and the ball's X is 40. So at this moment in time, my X is not less than the ball's X. I mean, sorry, my X is less than the ball's X because I'm at -9, and he's at 36. So oh shoot, I just said that backwards. I'm going to confuse you to death. Sorry, because that's not what I ask. Here. let's turn this around and ask what I was just saying. Let's say my x position is my x position less than the x position of the ball. My x position is -10, the ball's x position is 44. So at this moment, this picture, my x position is less than the ball's x position. So what direction should I face? Well, turns out it's actually facing in the correct direction, but let's do this. Point in direction right. Now, what if that wasn't true? I'm going to just change this picture. Now, in this picture, my x position is not less than his x position. When so this else statement is the opposite of this. So when that didn't happen, right? When my x position was not less than his, I have this picture. That means I should face to the left. So basically, all you're going to do is you're going to make some decisions. Now, I'm going to run this. You watch this guy. He's not going to move. He's just going to turn. Or not. Oh, hold on. I have him set up not to turn. Let's try this again. Okay. Now watch this. So just watch the green guy in relation to the ball. He's always making a decision about what direction he should face based on his x position compared to the ball's. So when his x position is smaller than the ball's x position, he needs to face to the right. Otherwise, he needs to face to the left. And so take a look how awesome he is. Now you can throw in some move blocks as well. You can make all sorts of other decisions, but the important thing is you can make a decision based on something else that's on the screen. So just by comparing your x position to the ball's x position, you can make the right decision and then do your movement, and you have a computer-controlled enemy.